Okay, so I'm Jim Ingraham. I am Vice President of Strategic Research at EPB in Chattanooga, Tennessee. I want to talk about a project we have underway here at EPB. The foundation of it is really our belief that energy and the internet will eventually converge together as a utility based on quantum technology. So who are we at EPB? We are a municipal utility. We have about 350,000 electric and broadband customers in East Tennessee and North Georgia, but the center of our service territory is really around Chattanooga, Tennessee. Pretty much every year since 2016, we have been rated #1 in customer service for electric distribution and internet by both J.D. Powers and Consumer Reports. Our brand really is platinum customer service. In 2009, our company had actually no debt, and we did a $228 million revenue bond offer at that time to build a fiber optic network and smart grid in our service territory over 10 years. We deployed over 1,200 automated switches and AMI to every electric meter in our service territory. That took us from 11 million data points a year to 4 trillion. And we deployed a fiber to the home network that passes every home and business in our service territory. That investment in 2009 was forecast by an in-plan study I commissioned. It's used basically to say, what's the economic impact on a community if you build a sports stadium, an airport, a hospital, that kind of thing. Said over 10 years, we would see $600 million of benefit. 10 years later, I commissioned a study to look back at the actuals. It was close to 2.8 billion value to our community. This month, building on the EPB Fiber Optic success, we announced that we have deployed the Nokia 25 PON technology on network electronics onto our fiber system. It's a 3-year, $70 million capital investment, which we'll complete next year. But we now offer 25 gigabit symmetrical internet to anybody who wants it in our service territory. Our first customer was our convention center, and it will allow for a multi-port fiber connection through the optical network termination point to any customer. So if you want to work from home, go to school from home, game from home, you can have multiple fibers into your home to make those things come to life. We believe that the Nokia 25 PON network electronics will keep us on the cutting edge of internet service for the next 10 to 15 years. At the same time, we have invested $6 million in what we call the EPB Quantum Network. We have been doing entangled photon research on our fiber optic network with the Oak Ridge National Laboratory, the Department of Energy, and Cubatech out in San Diego, really since 2016. We started into the telephone business in 2000 by leveraging a downtown fiber loop that was part of the electric system. We're repeating that history. We're building a 7-mile fiber loop based on the OFS new low latency fiber that will pass through our building, through the Edney Innovation Center, which is a business accelerator in town, and across the campus of the University of Tennessee, Chattanooga. And it will include several of our substations, but it will give us a loop architecture, which will allow us to move these photons continuously around the track 365 days a year, 24 hours a day, 7 days a week. We believe, and it is designed to be one of the first commercial quantum networks for researchers in our country. Why would we invest $6 million in building such a network today? Again, like I say, we've been working in this quantum space for some time now, getting some experience in that area. I mentioned that we believe that energy and the internet will converge, and quantum technology will be a key driver of the convergence. Electric distribution systems are distributing today. Transportation is electrifying. Electrification of transportation is the first new revenue stream in the utility business and the energy business since the advent of air conditioning. Those vehicles will become autonomous in time. The internet is already becoming a virtual environment. You call it a spatial internet, Web3, you can call it the metaverse, call it whatever you like. I don't know what it will turn out to be, but we believe it will be a fully immersive integration of the real world and a spatial world where we will be living part of our lives, not in a two-dimensional way, the way we are communicating right now, but in a three-dimensional way. There will be decentralized finance in that world. Trade and commerce will change. Business will exist in it. Quantum networks will be key to making that world come to life. And we believe that it's going to be critical to managing the data, learning to manage the applications that will make the future utility services in our country more efficient, more capable of supporting economic development and quality of life. So why are we in quantum now? It's early. Regularly, as I attend these QED-C events, I hear regularly, these things are a long way off. There are a lot of reasons we're getting involved. We're not involved with this company, IonQ, but this is a story from the media. IonQ makes a quantum computer. There was a story in the trade press that was basically a hit job by an outfit called Scorpion Capital. They claimed that that IonQ's technology, which is traded on the NASDAQ, didn't work. And then they shorted the stock. And basically, IonQ had to go to work to refute these rather shady characters at Scorpion Capital. We believe networks like ours that don't really exist today, as far as we know, will be a platform to prove new quantum technology's efficiency, to prove its performance improvement over time. That will show that the technology is investment grade, that is evidence of that. That will allow you to forecast time to revenue, and it will allow a mechanism to protect your brand. We believe this is one of the applications our network will be useful and valuable to. Because it is a commercially available network, it's available to the private sector, to university researchers, to federal agencies, to anybody who wants to do quantum research. Our employees, we want them to learn what this quantum world is. These are some of our engineers and technicians. And then on the right, these are some of our young people that we're actually training for the future to work in our company. When you say quantum today, quantum networks, quantum computing, quantum sensing, quantum worlds, people don't know what you're talking about yet. But we are getting our workforce ready. In January, when we told our engineers we're going to build this network, they had a fit. If you know anything about engineers in the utility space, change comes hard for them. But 6 months later, they know what we're doing and they're on board. We want our employees and our community to know what we're doing. We also want our workforce to be ready for this quantum world, to build the equipment, to be technicians who will support the technology, including the engineers and scientists who will develop the next generations. We've been doing quantum key distribution research on our network. As I mentioned, we have a roadmap to a quantum protected network. I guess you can call it either one. This is Steve Morris, who's our cybersecurity director, but we will be using our network to move in the direction of protecting our critical infrastructure from any kind of intrusion. We believe the quantum technology will play a role in both our energy and our internet businesses. In the center here, you see one of our customer service reps in 2020. And again, we're as good as you get in the United States at that. This is what we think that customer service rep's job will look more like around 2035. On the right, you see a control center from Northrop Grumman. We think our control center will look more like this in the future. And we believe that the quantum technology will create applications that allow us to do things like learn how to charge electric vehicles faster. It's an AI, AR, VR, quantum age kind of service delivery environment that we want to be prepared for when it comes. I mentioned our Nokia 25 PON network. We went from 11 to 21 super nodes or huts, distributed electronics on our system. We're pushing the electronics closer to the customer. When the time is right to invest and build a quantum network for our community, we want to know how to do those things. And we're starting today to learn how to do that. But we want to be prepared for that when the time comes. When we deployed our fiber to the home network, and we were one of the early communities to deploy symmetrical gigabit service, we were kind of branded Gig City. We hope when the time is right, our quantum network will lead us to be one of America's quantum cities. And this is how we hope to maintain both our community and utility leadership in the future.